And welcome back. Now this week I've got a problem. Basically it's my smartphone charger that's been around for about 2 or 3 years and now suddenly it's obsolete. What do I mean? Indeed, it is obsolete because this phone that's plugged into this Huawei phone that I've had for, I don't know, 3 or 4 years or something. Very good it is too, although as we know Huawei is now persona non gratis as far as electronic equipment is concerned, so I can't get Android running on any kind of Huawei phone. I've bought a new one because basically this phone, even though it's probably 3 to 4 years old, I can't remember exactly, but it's only got 8 gig of storage internally. No, not runtime memory. This is storage, right? So there's 8 gig in here, and that's tiny. I didn't realise that technology had moved on such a pace. If making a PCB is a bit of a puzzle to you, let JLC PCB help you put all the pieces in the right place. Easy EDA is an intuitive electronic design tool, just as I'm showing you here. And when you've done that, you can convert it into a PCB like this one here. And you can view it in 3D and see exactly how it's going to look before you order it. It's easy to order from JLC PCB directly from within Easy EDA, with fast, reliable deliveries and now $2 for 5 pieces, including aluminium boards. They can even assemble them for you at no extra charge. Why don't you see what JLC PCB can offer you today? But I was getting loads and loads of messages coming back saying, you know, your storage is full, you've got to clear some out. And I kept clearing it out because every time somebody sent me a WhatsApp message with a photo, back comes the mail, oh, it's full. Now, I tried to mitigate that by putting a SD card in here, yes, 128K, and getting all the photos and stuff on that, and that worked for a bit. But then the messages start coming back again. It was getting very slow. Eventually, I mean, it's been like that for about 6 months now, and eventually it's just got to the point, I think, what is there out there? Yeah. In fact, this was all triggered by my friend up in Yorkshire saying, oh, I bought a new phone. I've got a Samsung A22 5G. And I'm thinking, are there any 5G phones out there? Have I been living in a cave or what? So I had a look, and of course, once you start looking, it's very dangerous, isn't it? So what I've actually got is this big thing here, which I will turn on just to show you. It's a real phone. There we are. That's a real phone. Yeah. So it's a bit bigger than that one, 6.5-inch screen. But more to the point, it's got 6 gig of runtime memory and 128 gig of internal storage. So what's that? 8 times the storage of that one? It's ridiculous. So I thought that's what I need, something like that. Yeah. And of course, the power of the actual phone is a lot, well, better. I mean, it's just, everything is just quicker and smoother. And anyway, that's not what I'm here to talk about. Okay, I don't want to brag about my phone because I consider a phone a bit like a washing machine or a cooker. You know, it's a utility, isn't it? Piece of equipment. I just use my phone for, well, the occasional photograph when I'm doing sort of videos like this or Amazon reviews, WhatsApp messages, phone calls even, would you believe? Yeah, I know, it's strange, isn't it? But not much else, apart from, of course, using it to control this. So this you've probably seen in a previous video. I did a whole thing about it, yeah, how wonderful it was and all that. I'm very happy. And the driver for this project in the first place is that this phone says, the old phone that is, yeah, it says you can, as an option, pretend that 80% full battery is in fact 100%. If you flick a little slider in there, it goes, I'll treat 80% as 100% and stop charging at that point to prolong the life of your battery. Now, I've known this for a long time, that if you keep charging things up to full 100% all the time, and especially if you keep it there, that poor battery, it's like, it's going to explode. It's got so much power in it. It's a bit like leaving a hose pipe connected to the tap and the tap on. It's, you know, it's under pressure, isn't it? So I thought, okay, if Huawei consider it important enough to say I'll treat 80% as 100%, I can make it a bit more flexible than that. So I designed this little project here that basically reads the battery charge rate from here using Bluetooth. Right, so they're connected using Bluetooth, or in this case, as you can see, not connected. But basically, this sends out the battery percentage to this, and this is then controlled by just a standard Pro Micro to say, at what point do you want me to stop charging? And I've set it, I think, currently to 92% or something. And once it hits 92%, it's on a little slider. It stops, and then it gradually sort of discharges because I leave the phone on all day. And when it hits something like 80%, it goes, oh, I've got to start charging it. So it goes between 80 and 92, as an example, right? Great. So that means the battery is never overcharged, and more to the point, once it gets to 92, then the pressure's off because it's not charging anymore until it goes down to 80, and that should have extended that battery, and indeed I've had zero trouble with that battery. Previous phones, I've found, as Apple users have also found in the past, that the battery power starts getting less and less and less. You have to charge it more frequently. Whether that is the cause, I don't know, but it sounds possible, doesn't it? So this works well, and I like it, and I want to keep it. I want to keep it running. Now, what are the issues then? Well, there are manifold, but okay, let's start at the top, shall we? It's connected via a simple USB plug here, except it's not a simple USB plug anymore. It's magnetic, right? So this cable, this red cable that you can see I've hacked, basically I bought the cable, cut it, soldered it in here to come out here again, and soldered the other end, which is a standard USB-A type plug at the other end, onto this end, right? And as you can see, hopefully from that, there's a light on here, by the way, that's why it looks a bit washed out. It's just the center pin there that's the positive, and this outer ring that's negative. And it goes onto that little magnetic thing at the back. You hear that snap on there? Look, it's magnetic. Yeah, Apple users will know this. They've had it for years. Anyway, I found these 3 years ago, or whatever, and I've used it ever since. Basically, because I didn't want to keep plugging the USB plug into there, because the socket would almost undoubtedly wear out after a short while. They're not exactly robust, are they? Micro USB, that is. And it means also I can put this phone in my car and have exactly the same sort of situation with the cable, and it just snaps on and charges my phone while I'm in the car. Admittedly, I haven't got this in my car, so on long journeys, yes, it does move it all the way up to 100%, but my long journeys are infrequent, so I'm prepared to live with that. Great. So along comes the new phone. Okay. Now I'm probably going to have to zoom back out because it's so big I can't even get it on screen. So this is a Xiaomi, or Xiaomi, I don't know how to say it, Ziaomi. I did read, obviously I did some research before I bought this phone, and there's sort of a contender for Samsung, and I thought, Samsung do a great range of phones, of course, the A series, which is the budget range, which is what I suppose this comes into, and of course their S series, which is, well, S stands for stupidly priced. Yeah, I know, one of their phones is easily over £1,000. I could buy a whole PC for that. So I wasn't in that kind of price bracket at all. This one cost me £200 actually, so that's about a middling sort of price, isn't it? And for the performance and everything else, I read up all the specs and what it can do and all that gubbins. As I say, this is a washing machine as far as I'm concerned. It's not exactly exciting, but I read up all the specs, compared it against this, that and the other, and it came out basically on top. It did everything I wanted, including have a fingerprint sensor on the side here so that I could do all my online banking as well. That's another thing I use it for. Great, I thought I'm going to stick it in this holder that I've put on the top of here. Get another one of those USB adapters for underneath. So this is the magnetic adapter I was talking about. That's just, oh, take it out. See, that's the USB micro thing that just plugs in, and that center one is the positive, outer ring is the negative. I'll just put one in here, and Bob's my uncle. Except, of course, it never that simple, is it? Because this one, as you can probably see, is in fact a USB-C type socket. Yes. So, yeah, that was never going to work. Now, as it happened, when I bought those magnetic connectors, I bought a whole bunch of them, I'm pretty sure that with one of them, with this cable in fact, there was a USB-C that came with it. Do you think I can find it? I mean, because up to now, USB-C has not really figured into my life, not really. I can't find any USB-C ones that I've got, but I thought, okay, well, you can buy them easily enough from, AliExpress or something like that. I would think. I haven't checked yet, but I think even Amazon probably sell them. So I thought, okay, we'll stick a USB-C one in here and, well, connect this back up again and Bob's my uncle, right? Yeah, sort of. There is an issue though. This phone, when connected to the proper charger, which is this one here, does all sorts of charging things. It even says it underneath somewhere on here. So there, you can just see that little tiny right. Yeah, I know you need a magnifying glass to read it. So I wrote it out because I couldn't read it all. And this is what it says. Let me turn that light off. Right, there we are. So what it says is, I'll charge this at 5 volts at 3 amps. That's pretty high in itself. I mean, the standard USB charging could only be anything from 5 volts, 1 amp, 2 amps. So 3 amps is quite high, even at 5 volts. But this is adaptive charging. So it's a USB-C PD, power delivery type socket, which means it negotiates with the charger. The phone and the charger talk to each other. And this says, oh, I'm really flat. I need more power than that. I want to really suck it in. So it goes, well, I can charge you at 9 volts at 3 amps, or 12 volts at 2.25 amps, or 20 volts at 1.35 amps. And that's 27 watts, 27, 27, 15. Or right down the bottom, it says 11 volts at 3 amps, which is the 33 watts maximum, which is what that charger is sort of advertised at, 33 watts power. Now, which one of these it chooses, I have absolutely no idea. It's the negotiation between the phone and the charger as to which one you get. And it might charge rapidly, very, very quickly, but as it hits the sort of 80, 90%, it then starts slowing down so it doesn't, run into a brick wall. And it trickles the last few percent in. What I have noticed is, though, when I plug in that proper charger and the lead that came with it, this thing says, "Oh, I'm running on Super Boost, whatever charging facility," and it doesn't tell me what it's using here, but it does charge up exceedingly quickly. I mean, in 10 minutes, it can go from like 30% to 60% or something. It's ridiculous how fast it can charge compared to the old phone. That took a couple of hours to charge. So I'm thinking, all right. Do I want to utilize this and think, okay, I can charge quick on here, even though the whole point of this is to sort of, calm things down a bit. I think, well, if I set the app on here to say, well, we'll charge up to 85%, something like that, maybe 90%, but don't charge again until you're down to 60%. Is that going to be kinder to the battery? Don't know. But I thought, well, I've got two choices here. I'll either find a USB magnetic thing and just stick it in here and that's it. And it charges then 5 volts at 3 amps, which could be enough, except I don't think you'll get 3 amps through here. Don't think so. The most I've ever had through here at any one time is about 1.2 amps. Because there's obviously a current measuring device in here, INA something or other. I'll show you what that is. There it is, it's on the screen. So there's a little resistor it has to go through to measure the voltage drop across it. But I'm thinking I can't use that with a fast charger or an adaptive charger. Let me show you the circuit. So this is the circuit from way back May 2020. That was the new phone. That was that little ding. And as you can see in red here, it says, "Note: fast chargers do not use," because the specification for a fast charger, it'll run from 3 volts to 21 volts in 20 millivolt steps, which sounds, I don't know, very small, isn't it? 20 millivolt steps. 0 to 3 amps in 50 milliamp steps. Increments via USB PD. PD stands for power delivery. Okay, so this is not designed for anywhere near, well, anything over 5 volts, because the Pro Micro is connected directly here to the USB input socket. So in order for me to change this circuit, I would have to have the input USB-C port socket here have a voltage regulator, an LDO, low dropout voltage regulator, to get the 5 volts-ish here to run all this, well, in fact, to run everything. And then another USB out here that basically connects the wires from here to here. And I thought, okay, these wires were connectable because I think there was 5 in all. You can see there, yeah, 5 wires. I could do that. As it happened, I think it only used 2. Well, the power, basically. Yeah, I thought, are the data lines used at all in just charging something up? The answer is no, not on USB, well, micro USB, USB 2. Although USB-C could also be USB 2. I know, it's a minefield, it's a minefield. So I thought, okay, what's the charging arrangement these days for USB-C? That's a minefield too. I've found that the USB-C socket has 24 connections in it, as shown here, right? Normally. But it says, oh, if you just want charging, you can get away with 6 or 8, like these ones here, right? There's a 6, and there's an 8. I think, great, thank goodness for that, because that means I can probably wire that up okay-ish. And then, of course, as these big arrows point out, it says, please note that since the data transfer pins of the USB 3 socket are not present, the power transfer negotiation does not happen, and it will stick at 5 volts at 1 amp. And I go, well, that's ridiculous, absolutely ridiculous. We've got all this adaptive power capability, and because we're putting on these simple little sockets, all that goes out the window. Now that might be fine for charging up, say, my cordless vacuum cleaner that charges up every now and again, and you just leave it in until it stops blinking because you just don't care really. Although even then, fast charge would probably come in quite handy. But anyway, you're just not that bothered. Yeah, and that's probably what it uses, this sort of arrangement. But I thought, no, I want it, if I'm going to change this board and everything else to USB-C, then I want it to work properly. So it looks like I'm going to have to keep in the data lines, so that the proper communication can happen and it will start charges up quick. Okay, where does that leave me then? Well, what it leaves me is this thing here. Now this huge big socket picture that I've got here, you can see all the lines on it at the top there, all these lines. Now they're sort of duplicated because obviously the USB-C, one of the advantages that you can flip it either way, right? There's no more, can I get it in this way? No, it must be the other way. No, it wasn't that way after, it must have been that way. That's madness, isn't it? I know. So USB-C, you can plug it in either way. Now, in order to do that, these pins you see here at the top, they're basically flipped and duplicated. So B12 here is pretty much the same as A12 there, and A11 is the same as B11, and so forth down the lines. The two in the middle are a little bit different because the data lines are in fact connected together, D plus and D minus, and there's a couple of other that mustn't be connected, so that it can work out which way round you've plugged it in, as far as my understanding goes. But I look at this, there are so many of these little tiny connections, I think, come on, I am never going to be able to solder those onto my new PCB. Just isn't going to happen. So I think, okay, what do? Do I get JLC PCB to solder them on for me? And they can do. It's an extended part though, so it costs money to get that particular thing soldered on. But I'm thinking I cannot get a USB-C cable, cut it like I've done with this one at the back here, and solder each one of those wires on with any hope of success. I mean, it's just nonsense. I'm not even going to go there. So one of the options then is to take these sockets that JLC PCB have in stock, was part of the LCSC component line, and say, right, I design my board and you solder them all on. Now, the thing is, this isn't a surface mount one, so I don't even know they can do that. I'm hoping they can. I've got to investigate a bit more yet. But because it's suddenly turned into a bigger job than just getting a magnetic plug-in thing, I'm thinking, am I making a mountain out of a molehill? But I just know if I don't do anything with that charger of mine and just keep it like this, so that if I keep it like this and just plug it in there at 5 volts at 1 amp or whatever, I'll be niggled forever and a day. Whereas with this one at the moment and my old phone, I was really happy with it. You know, it worked pretty much as I'd designed it, and yeah, it's great, all working well. So if I now cut corners and go, I'll just stick a USB-C thing in there, magnetic one, that'll be all right. Well, it'll be all right-ish. It'll work, it will charge up the phone, but I know that it's not as good as it could be by any means. So I really should get this board, this one here, look, redesign it, put proper sockets on somehow, get somebody to solder them on, not me basically. Unless, of course, you guys know differently. If you think, no, you could do it like this and you only need 2 of those data lines or something, because I'm still reading up even as I'm videoing this, because I've been doing this now for like 2 days. How much do these things cost, these USB-C cables anyway? Let's have a look. Now, call me cynical. Cynical? Yeah, I thought you would, yes. I found this on Amazon, right? Now, it's only $3.99, it says there. Look for this Type-C 3-foot fast charging cable for, okay, Samsung it says there, but I guess it's for any USB-C type device. But I'm thinking, is this the right one that does this negotiation? Or does it just, when it says fast charging up here, does it mean I'll just allow lots of current to flow down this wire without melting it for you? I'm guessing you guys know better than me, because I'm new to this USB-C game, I must admit. That's something else to think about then, isn't it? Yeah, so this is the wiring of that plug. If you think I could wire that onto a PCB board, think again. Now, this particular site does tell me quite a bit about what it all means and what connects to what and why. So yeah, here it tells you all about all the pins are about again, like we did before, and there's loads of information. I'll put all this information down below with all the correct attributions so you can find out where I got it from, because it's a minefield, quite frankly. It is a minefield. So I'm going to leave it there, because my goal is to investigate a bit more fully, to think, how can I make this phone charge as it should be charged via that super duper power delivery system, and what's that going to mean for me in terms of, well, cost, not just money. I don't mean money cost, I'm talking about effort and getting it working and all that. Obviously this PCB is no good anymore, because I'm not going to be cutting cables like I did for that one and feeding it through. So I've got to understand exactly what sockets I need where, who's going to solder those sockets on. If I can crack that bit, I think, right, now I know what to do, because I've already got the circuit. I just need to add something like an LDO, as I said before, 5-volt LDO to power all this, and make sure that it can pass the 20 volts from one socket to the other without interfering with all this stuff on here. I'm going to stop there. I'm hoping that some of you guys out there watching this know about USB-C more than I do and can give me some pointers. But if not, well, I'll just keep reading and figure out what I need. Worst comes to worst case, I can temporarily get one of those magnetic things to stick in the bottom, so at least this works at a sort of reduced functionality, just standard 5 volts. But I do want and hope to stick the full caboodle on here. Yeah, I know it's a technical term again. I'm making it up as I go. Yes, I know. If you think you can help, please do put a comment down below. Not least because I need the help. Yeah, I know. And this is going out Friday, so this is a short turnover, this video. Normally they're done several weeks in advance sometimes, but this is going to be short because it's a real-time project, isn't it? I want to get it up and running. And now, if you found it moderately entertaining and useful, do give it a thumbs up, because YouTube likes that, and that helps my channel get a bit more exposure, which is always good. And until we meet again, see you in the next video. I hope you're finding these videos useful and interesting. There are plenty more videos to choose, and a couple are shown below. And if you'd like to subscribe to this channel, just click on my picture below and enjoy the rest of the videos. Thanks for watching.